thing you should know is that if you have 1 over 5 to the power 3, then that can be written as 5 to the power minus 3, so p is just minus 3. The second one, you have got 5 to the power something equaling 1. Well, you should know that anything to the power 0 is 1, so q is 0. And lastly, you should know that if you have a square root and a power, you can write it as a fractional power, where the bottom of the fraction is the type of root and the top of the fraction is the type of power. So 5 to the power 3 over 2 is the same as the square root of 5 cubed, so r is the same as 3 over 2. Okay, next we have got 14 over the square root of 245, and we need to simplify that. Now the first thing we need to do is remember that if we multiply the top and the bottom by the square root of 245, it gets rid of the square root on the bottom. We don't like surds on the bottom of a fraction. So the top just becomes 14 root 245, and the bottom, because we are squaring the square root of 245, it is just 245. Right, the next thing I need to remember is that we don't like big surds, so we don't like square roots which contain large numbers. So I'm going to rewrite the square root of 245 as two numbers multiplied together where one of them is square. Now with a bit of investigation on my calculator, I can know that 245 is actually the same as 49 times 5. So I can write this as the square root of 49 times 5. And I can then split that into 14 times the square root of 49 times the square root of 5, because I'm allowed to split a square root like that. And on the bottom I've got 245. So the top then is the same as 14 times 7 times root 5, and that is over 245. Now I could simplify that on my calculator, or I could remember that actually I know that 245, so the top is 14 times 7 times root 5, and the bottom, remember 245 was 49 times 5. Well, I can cancel here. The 14 and the 49, well, how many 7s in 14? Well, that's 2. How many 7s in 49? Well, that's 7. And now the two 7s cancel and become 1 and 1. And I'm left with now on the top 2 root 5, and on the bottom I've just got 5, which is what I was after. Okay, this one, it's fairly obvious that the first thing I need to do here is remove the bracket. So I'm going to do e minus 2 root 3 squared. Now, remembering that when I square a bracket, it becomes e minus 2 root 3 multiplied by another e minus 2 root 3. I realise I need to multiply the bracket by the bracket. Now, the easiest way, I think, with surds to do the multiplication is to use the grid method. So I'm going to write e and then minus 2 root 3, and again e and minus 2 root 3, so I can sort out the multiplication. So first of all, e multiplied by e, well, that's e squared. I'm then doing e minus 2 root 3, well, that's just minus 2 root 3, and then e, and it's the same here, minus 2 root 3 e. And then I'm going to do minus 2 root 3 times minus 2 root 3. Well, that's going to come out as positive. If I do 2 times 2, well, that's 4. And if I do root 3 times root 3, well, that's just 3. So that just bit comes out as just 12. Okay, so this is 12. So when I remove the brackets here, I'm going to get e squared minus, now it's 2 root 3e minus another 2 root 3e, which is minus 4 root 3e, and then plus 12. Okay, now I am told that that expression there, so e squared minus 4 root 3e plus 12, is equal to f minus 20 root 3. Now, this is the clever bit. Basically, on the left-hand side of this equation, you have got some rational parts and some irrational bits, and the irrational bits are the bits that contain the square root. Okay, so if you like, I'm going to change the order. This bit here on the left-hand side, okay, the minus 4 root 3e, that is the irrational bit, the bit that contains the square root. And on the right-hand side, the bit that contains the square root is that bit. So because I know that the left-hand side and the right-hand side are going to be equal, because that's what an equal signs mean. For example, if I had this, 2 plus 3 root 5 is equal to, let's say, a plus b root 5. The only way that that could be true would be if a was 2 and b was 3. No other choice. Okay, the number of surds on the left and the number of rational bits on the left and right must be the same. So if I now compare these two, on the left-hand side, I've got minus 4 root 3e, and that must be equal to minus 20 root 3. And it doesn't take much to realise that if I just get rid of the surd bits, the minus 4e must be the same as minus 20, which means that e must be 5. Okay, now going back to my original inequality, so I know that e squared minus 20 root 3 plus 12 now is equal to f minus 20 root 3. Well, I can now forget the surdy bits. I know they're the same, and I'm now going to look at the rational bits. Well, on the left-hand side, I've got e squared plus 12, and on the right-hand side, I've got f. But I've just worked out that e is 5, so e squared is going to be 25, so 25 plus 12 must equal f, which means that f is 37.